Welcome to The Backbencher, a place where every learner feels seen, supported, and truly at home. Today, we're diving into trigonometry, what it is, why it matters, and how to understand it without stress. Stay with me and subscribe for more clear, simple study tips.
Trigonometry is a branch of mathematics that focuses on the study of triangles, particularly right-angled triangles. The word itself comes from Greek roots, tri meaning three, gono meaning angle, and metri meaning measurement. So trigonometry is all about measuring angles and sides in triangles. This field is essential not only in mathematics, but also in physics, engineering, and many real-world applications. Throughout this video, we'll explore the fundamental concepts, key formulas, and practical examples that make trigonometry such a powerful tool. Let's begin by understanding the basic elements and why right-angled triangles are so important in this subject. The heart of trigonometry lies the right-angled triangle. This triangle has one angle exactly equal to 90 degrees, making calculations and relationships between its sides and angles especially straightforward. The sides are typically labeled as the hypotenuse, the longest side, the opposite side across from the angle of interest, and the adjacent side next to the angle of interest. Understanding these terms is crucial because trigonometric ratios are defined based on these sides. As we move forward, keep in mind how these sides relate to each other and to the angles within the triangle. Trigonometric ratios are the foundation of trigonometry. The three primary ratios are sine, sin, cosine, cos, and tangent, tan. These ratios relate the angles of a right-angled triangle to the lengths of its sides. Specifically, sine is the ratio of the opposite side to the hypotenuse, cosine is the ratio of the adjacent side to the hypotenuse, and tangent is the ratio of the opposite side to the adjacent side. These relationships allow us to solve for unknown sides or angles in triangles, making them incredibly useful in a variety of mathematical problems. In addition to the primary trigonometric ratios, there are three reciprocal ratios: cosecant, CSC or cosec, secant, sec, and cotangent, cot. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. These ratios are especially useful when solving more complex trigonometric equations and identities. Understanding both the primary and reciprocal ratios gives you a complete toolkit for tackling a wide range of trigonometric problems. The coordinate plane is divided into four quadrants, each affecting the sign of trigonometric ratios. Starting from the positive x-axis, the quadrants are labeled anticlockwise. In the first quadrant, all trigonometric ratios are positive. In the second, only sine and its reciprocal are positive. In the third, only tangent and cotangent are positive, while in the fourth, only cosine and secant are positive. This knowledge is essential when solving trigonometric equations, especially for angles greater than 90 degrees. Angles in trigonometry are measured from the positive x-axis, moving anticlockwise. Positive angles follow this direction, while negative angles move clockwise. This convention helps in determining the correct values for trigonometric functions, especially when dealing with angles outside the first quadrant. Remember, the reference angle is always measured from the x-axis, and this helps in finding the correct sign and value for the trigonometric ratio. Each quadrant has a specific way to calculate the angle based on the reference angle. In the first quadrant, the angle is simply theta. In the second quadrant, it's 180 degrees minus theta. In the third, it's 180 degrees plus theta, and in the fourth, it's 360 degrees minus theta. This system ensures that you can always find the corresponding angle in any quadrant, which is crucial for solving trigonometric equations and understanding the behavior of the functions. Angles are classified based on their measure. An acute angle is between 0 degrees and 90 degrees and lies in the first quadrant. A right angle is exactly 90 degrees. An obtuse angle is between 90 degrees and 180 degrees, found in the second quadrant. A reflex angle is between 180 degrees and 360 degrees, spanning the third and fourth quadrants. Recognizing these types helps in identifying where an angle lies and which trigonometric ratios are positive. Solving trigonometric equations often involves finding all possible values of an angle within a given range. For example, if you're asked to solve 3 cos theta plus 2 equals 0 for 0 degrees less or equal to theta less or equal to 360 degrees, you first isolate cos theta, then use the quadrant rules to determine all possible solutions. The key is to find the principal angle, then use the quadrant relationships to find all valid angles within the specified range. In solving trigonometric equations, the angle you first find is called the key or principal angle. This angle helps you determine all other solutions in the specified range by applying the quadrant rules. Remember, the key angle itself may not always be a solution, but it guides you to the correct answers. Certain triangles like the equilateral triangle and the 30-60-90 right triangle have special properties that make them useful in trigonometry. For example, in a 30-60-90 triangle, the sides are in the ratio 1, square root 3, 2. These triangles help us derive exact values for sine, cosine, and tangent of 30 degrees, 45 degrees, and 60 degrees, which are commonly used in problems and identities. Trigonometric identities are equations that are true for all values of the variable. The most fundamental identity is sin 2 theta plus cos 2 theta equals 1. Others include 1 plus tan 2 theta equals sec 2 theta and 1 plus cot 2 theta equals cosec 2 theta. These identities are essential for simplifying expressions, proving other identities, and solving equations. Mastery of these relationships is key to success in trigonometry. Pythagoras' theorem is a cornerstone of trigonometry. It states that in a right-angled triangle, the square of the hypotenuse equals the sum of the squares of the other two sides. A 2 plus b2 equals c2. This theorem not only helps in finding missing sides, but also underpins many trigonometric identities and relationships. Many trigonometric equations require the use of identities for their solution. For example, to solve sin 2 theta plus 1 plus cos theta, 2 equals 2, 1 plus cos theta, you expand and simplify using the basic identities. This process often reveals hidden relationships and makes complex equations much more manageable. Graphs of sine, cosine, and tangent functions reveal their periodic nature. The sine and cosine functions oscillate between -1 and 1, repeating every 2 pi radians, 360 degrees. The tangent function, on the other hand, has a period of pi 180 degrees and can take any real value. Understanding these graphs helps in visualizing solutions and predicting the behavior of trigonometric functions. Angles can be measured in degrees or radians. One full revolution is 360 degrees or 2 pi radians. To convert degrees to radians, multiply by pi/180. To convert radians to degrees, multiply by 180/pi. Radians are especially useful in higher mathematics and calculus, so it's important to be comfortable with both units. The length of an arc and the area of a sector are important applications of trigonometry in circles. The arc length L is given by L equals r theta, where theta is in radians. The area of a sector is 1/2 r2 theta. These formulas allow you to solve problems involving parts of circles, which are common in geometry and real-world contexts. In solving trigonometric equations in radians, always ensure your calculator is set to the correct mode. The process is similar to solving in degrees, but the answers are given in terms of pi or decimal approximations. This is especially important in advanced mathematics, where radians are the standard unit.
If this breakdown is helping you understand trig better, consider subscribing. It really supports the channel and helps more students find these lessons.
Compound angle formulas allow you to find the sine, cosine, or tangent of the sum or difference of two angles. For example, sin alpha plus beta equals sin alpha cos beta plus cos alpha sin beta, and cos alpha plus beta equals cos alpha cos beta sin alpha sin beta. These formulas are essential for simplifying expressions and solving equations involving multiple angles. Double angle formulas, like sin to theta equals 2 sin theta cos theta and cos to theta equals cos 2 theta, sin 2 theta, help in expressing trigonometric functions of double angles in terms of single angles. Half-angle formulas are also useful, especially when integrating or solving equations. These identities expand your ability to manipulate and solve trigonometric expressions. When faced with equations involving compound angles, use the relevant formulas to break them down into simpler components. For example, to solve cos theta plus 35 degrees equals sin theta plus 25 degrees, you can use the identities to rewrite and solve for theta. This approach is powerful for tackling more advanced trigonometric problems. The t formula is a useful tool for solving trigonometric equations. By substituting t equals tan theta/2, you can convert trigonometric equations into algebraic ones, making them easier to solve. This technique is especially handy for equations involving multiple trigonometric functions. Trigonometric functions have maximum and minimum values within their periods. For example, the maximum value of sin theta is 1, and the minimum is. For functions like a sin theta plus b cos theta, you can use the amplitude formula to find the extreme values. This is important in both pure and applied mathematics. Many trigonometric expressions can be rewritten in harmonic form, such as r sin theta alpha or r cos theta plus alpha. This makes it easier to analyze and solve equations, as well as to find maximum and minimum values. The process involves using identities and comparing coefficients. Inverse trigonometric functions, such as arcsin, arccos, and arctan, allow you to find the angle given a trigonometric ratio. These functions are essential for solving equations where the unknown is an angle, and they have specific ranges to ensure unique solutions. Solving triangles means finding all unknown sides and angles given some initial information. This often involves using the sine rule, cosine rule, or trigonometric identities. These methods are widely used in navigation, engineering, and physics to determine distances and angles in real-world scenarios. The sine rule relates the sides and angles of any triangle, not just right-angled ones. It states that a sin A equals B sin B equals C sin. See, this rule is especially useful when you know either two angles and one side or two sides, and a non-included angle. It's a powerful tool for solving oblique triangles. The cosine rule is another essential formula for solving triangles. It states that a 2 equals b2 plus c2, 2bc cos A. This rule is particularly useful when you know two sides and the included angle or all three sides. It generalizes the Pythagoras theorem and is vital for non-right-angled triangles. The area of a triangle can be found using trigonometry, especially when you know two sides and the included angle. The formula is 1/2. Absent C, this approach is particularly useful for non-right-angled triangles and is widely used in geometry and real-world applications. Hero's formula allows you to find the area of a triangle when you know all three sides. The formula is area equals square root S, SA, SB, SC, where S is the semiperimeter, S equals a plus B plus C slash 2. This formula is especially handy when no angles are given, only the lengths of the sides. Trigonometry is widely used in navigation and surveying, especially when dealing with bearings and distances. By applying the sine and cosine rules, you can determine unknown distances or angles between points, which is crucial in fields like aviation, marine navigation, and land surveying. Trigonometry is also used to find the heights of objects and distances that are difficult to measure directly. By measuring angles of elevation or depression and using trigonometric ratios, you can calculate unknown heights or distances, which is especially useful in construction and engineering. Trigonometry includes several factor and addition formulas, such as sin A plus sin B equals 2 sin A plus B slash 2 cos B slash 2. These formulas help in simplifying expressions and solving equations that involve sums or differences of angles. Mastery of these identities is crucial for advanced trigonometric problem solving. Sometimes you'll encounter simultaneous equations involving trigonometric functions. These can be solved using substitution, elimination, or by expressing the equations in terms of a single trigonometric function. This technique is especially useful in physics and engineering problems. In some cases, you need to eliminate a trigonometric parameter from a set of equations. This involves using identities and algebraic manipulation to express the relationship solely in terms of the variables of interest. This skill is essential for simplifying complex problems and finding general solutions. As you progress in trigonometry, you'll encounter more advanced identities, such as those involving triple angles, product to sum, and sum to product formulas. These identities expand your toolkit and allow you to tackle even more challenging problems in mathematics and science. Inverse trigonometric problems involve finding the angle when given a trigonometric value. These problems often require careful consideration of the function's range and the quadrant in which the angle lies. Mastery of these problems is crucial for high-level mathematics and applications. Trigonometry isn't just theoretical, it's used in countless real-life applications. From calculating the height of a building using shadows to determining the distance between 2 points on a map, trigonometry is a vital tool in science, engineering, navigation, and even art. Its principles help us solve practical problems every day. When working with trigonometry, common mistakes include using the wrong quadrant, forgetting to convert between degrees and radians, or misapplying identities. Always double-check your work, pay attention to units, and use the correct formulas for the problem at hand. Careful practice helps avoid these pitfalls. To succeed in trigonometry, practice regularly, memorize key identities, and understand the logic behind formulas rather than just memorizing them. Use diagrams to visualize problems, and don't hesitate to break complex problems into smaller, manageable parts. With consistent effort, trigonometry becomes much more approachable. Let's reinforce what we've learned with some practice problems. Try solving for unknown sides or angles in given triangles, use the sine and cosine rules, and apply identities to simplify expressions. Practicing a variety of problems will deepen your understanding and prepare you for exams and real-world applications. In this video, we've covered the basics of trigonometry, including trigonometric ratios, identities, solving equations, and applications in real life. We also explored advanced topics like compound angles, the T-formula, and solving triangles using the sine and cosine rules. Remember, understanding the relationships between angles and sides is the key to mastering trigonometry. Trigonometry is a gateway to more advanced mathematics, including calculus and analytical geometry. If you're interested in pursuing these fields, a strong foundation in trigonometry will serve you well. Continue practicing, explore new problems, and don't hesitate to seek out additional resources for deeper understanding.
Thanks for watching The Backbencher. Remember, it's not hard, you just don't know it yet. Before you go, drop a comment telling me what topics you want next and what I should improve to help even more students learn with confidence. New content will be posted soon. Thank you, and see you in the next session.